there is one experience that every human shares, of every language and culture, the experience of birth. Our recollections of birth are hazy at best. They have the feel and aura, not so much of memories as of mystical transfigurations. It would be astonishing if this profound early experience did not influence our myths and religions, our philosophy, and our science. The birth of a child evokes the mystery of other origins, the beginnings and ends of worlds, infinity and eternity. How did the universe arise? What was around before that? Might there have been no beginning? Could the universe be infinitely old?
Are there boundaries to the cosmos? The current scientific story of the origin of the universe begins with an explosion which made space itself expand. About 15 billion years ago, all the matter and energy that today make up the observable universe were concentrated into a space smaller than the head of a pin. The cosmos blew apart in one inconceivably colossal explosion, the Big Bang. And the stuff of the universe, together with the fabric of space itself, began expanding in all directions as they do today. We can visualize this process with a three-dimensional grid attached to the expanding fabric of space. The early cosmos was everywhere white-hot. But as time passed, the radiation expanded and cooled, and in ordinary visible light, space became dark as it is today. But then little pockets of gas began to grow. Tendrils of gossamer clouds formed, colonies of great, lumbering, slowly spinning things, steadily brightening, each a kind of beast composed of 100 billion shining points. The largest recognizable structures in the universe had formed. We see them today. We ourselves inhabit some lost corner of one. We call them the galaxies. We inhabit a universe of galaxies. There are unstructured blobs, the irregular galaxies, globular or elliptical galaxies, and the graceful blue arms of spiral galaxies. We've been investigating the galaxies, their origins, evolution, and motions for less than a century. These studies extend our understanding to the farthest reaches of the universe. Our ship of the imagination carries us to that ultimate frontier. We view the cosmos on the grandest of scales. The majesty of the galaxies is revealed by science. There are many different ways in which stars are arrayed into galaxies. When, by chance, the face of a spiral galaxy is turned towards us, we see the spiral arms made luminous by billions of stars. When, in other cases, the edge of a galaxy is towards us, we see the central lanes of gas and dust from which the stars are forming. In barred spirals, a river of star stuff extends through the galactic center, connecting opposite spiral arms. Elliptical galaxies come in giant and dwarf sizes. There are many mysterious galaxies, places where something has gone terribly wrong, where there are explosions and collisions and streamers of gas and stars, bridges between the galaxies. The galaxies look rigid and unmoving, but we see them only for a single frame of the cosmic movie. Their parts are dissipating and reforming on a timescale of hundreds of millions of years. A galaxy is a fluid made of billions of suns all bound together by gravity. These giant galactic forms exist throughout the universe and may be a common source of wonderment and instruction for billions of species of intelligent life. Their evolution is governed everywhere by the same laws of physics. We need a computer to illustrate the collective motion of so many stars, each under the gravitational influence of all the others. A billion years is here compressed into a few seconds. In some cases, spiral arms form all by themselves. In other cases, the close gravitational encounter of two galaxies will draw out spiral arms. But when two nearby galaxies collide, like a bullet through a swarm of bees, the stars hardly collide at all, but the shapes of the galaxies can be severely distorted. A direct collision of two galaxies can last 100 million years and spill the constituent stars careening through intergalactic space. When a dense, compact galaxy runs into a larger one face-on, it can produce one of the loveliest of the rare irregulars, a ring galaxy. Thousands of light years across, a ring galaxy is set against the velvet of intergalactic space. It's a temporary configuration of disrupted stars, a splash in the cosmic pond. Galaxies sometimes blow themselves up. The quasars, probably billions of light years away, may be the colossal explosions of young galaxies. But we're not sure. Quasars are a mystery still. The galaxies reveal a universal order and beauty, but also violence on a scale never before imagined. The universe seems neither benign nor hostile, merely indifferent to the concerns of such creatures as we. Quasars may be monster versions of rapidly rotating pulsars, or due to multiple collisions of millions of stars densely packed in the galactic core, or a chain reaction of supernova explosions in such a core. Some astronomers think a quasar is caused by millions of stars falling into an immense black hole in the core of a galaxy. Something like a black hole, something very massive, very dense, and very small, is ticking and purring away in the cores of nearby galaxies. Even a well-behaved galaxy like the Milky Way has its stirrings and its dances. The stars of the Milky Way move with systematic grace. The sun takes 250 million years to go once around the core. The outer provinces of the galaxy revolve more slowly than the inner regions. As a result, gas and dust pile up in spiral patterns. These places of greater density are where young, hot, bright stars form, the stars which outline the spiral arms. These hot stars shine for only 10 million years or so, and then blow up. But as the stars which outline a spiral arm burn out, new young stars are formed from the debris just behind them, and the spiral pattern persists. The sun, marked here with a circle, has been in and out of spiral arms often